hit the record button just locally on my desktop. Also not totally convinced this recording kind of format works, but we'll give it a shot. Anyway, so yeah, we're talking about the auto build pipeline, and step one, as you've seen, is basically anytime a repository is enrolled in the auto build pipeline, these webhooks get triggered. And so the instructions that an IG author actually needs to follow, the IG authors don't really need to understand much about the build pipeline, except that they need to opt into it by setting up a webhook in their GitHub repository. And I'll show you just a quick example of what that looks like so that we can talk about what happens in the next steps. So every IG right now is going to be set up to do a GitHub webhook push on every commit to this trigger function. So I'll show you an example in let's say the Smart App Launch implementation guide. So the author experience for somebody who wants to opt into this pipeline would be in their repository settings. They add a webhook, and you would click on add a webhook. Here I've already done that, so the details are here, and they're actually instructive because you can drill in to this webhook settings and see historically whether it's working and what payloads have been delivered. So like you can see, for example, there was an error here that said due to an incident, their webhooks were not delivered during what looks like a 30-minute block or so. So that's useful for debugging, but the reason I opened it here was just to get a quick look about the payloads. So every time a commit gets made, GitHub sends off a request like this to a cloud function that we have hosted. And so GitHub entirely defines the format of this message, and we don't use very many fields from it, but we use this ref in a very important way, and we use the information about the repository in a very important way. And basically, that's the only data we really care about. And so our cloud function parses this payload to pull out, like, what repository are we in? And what branch are we in? And once it knows those two things, it's able to proceed. It doesn't actually require any additional information beyond repository and branch at this point. And so the code for that trigger lives in GitHub in this IG commit trigger, and it's deployed to Google Cloud as a cloud function. And there's not a whole lot to it, but there's like a little JavaScript function that parses that payload that we were just looking at. So what does it do? It tries to pull out the repository full name, so that gives it the org and the repo, and it splits them on slash, so it knows the org and the repo that way. And then it tries to pull out the branch by looking at the ref value. And right now it defaults to master, although this code actually should never run. So if we're ever defaulting, something has gone wrong. So that way, in practice, regardless of whether somebody's default branch is master or main, that should actually be discovered here in line 39. It might be better for me to throw the error rather than defaulting here. And that way, if my assumption is incorrect that this code never runs, that would turn up. But that's basically what it does. It pulls out those three fields, org, repo, and branch, and then it kicks off what's called a Kubernetes job, which is to say it launches in our Kubernetes cluster an IG build job, and it passes in those three variables to the job. So we have a template for the job, which we can talk about sort of all this. It's just sort of a Kubernetes format that says what container to run, how much memory do you give it, what variables do you need. And then the only like really important things that it passes into that job are these three variables that we parsed out of the incoming payload. So that is sort of the transition, the boundary between what happens between GitHub and our webhook, and then between our webhook and the Kubernetes cluster. So let me pause there and see if that makes sense so far.
Yes. So this is a repository under FHIR, the Auto IG builder, where the actual webhook code lives. and this is where it is, and this is what it does, and this is the JavaScript that gets executed.
Yes, and you said that exactly right. All the code is sort of stored here, but it's deployed in a couple of different places. So this function is deployed as a Google Cloud function, and then all the Docker containers and so forth are running in a Kubernetes cluster. And so this repository is really just the central place where all the infrastructure code lives, and it's then deployed to various places to run.
And how is that deployed? That's a manual process, or?
Well, it is a, let's say, mostly automated but manually triggered process. So yeah, I'll give you an example. So the entire Kubernetes cluster, when it was originally set up 4 years ago, basically followed this pattern. And I won't go through the details of it, but we created a couple of persistent disks. We loaded some secrets and some configs, and that's more or less the state that the Kubernetes cluster needs in order to keep up to date. But then what happens when we change something is today basically a manual process. So I'll give you a quick example of what that looks like. So let's say there's a Docker container that's actually responsible for building an IG. That's the thing at the heart of these jobs that we're creating from the triggers. And so that Docker container is based off of an image, which is defined here in IG build. And so like last week, I made some changes to this image in order to basically lay the groundwork for a couple of features. So this commit message here has to do with something Graham pointed towards, which is the ability to supply an API key to the publisher. Graham said, the publisher is going to be talking to different terminology servers like the National Library of Medicine, and it's going to need to be able to have API keys. So I made a commit last week that basically, what did it do? It passes one additional argument to the publisher jar file when it runs, and it just hard codes a path on the container file system. So if this file is present, the publisher can use it, and if the file is absent, the publisher doesn't care, it just ignores this. So that's an example of a change to this image. To deploy this change right now requires a couple of manual steps. So what I do to deploy this change is I actually do a Docker build of this image and push it to the repository. And that way, the next time a job is kicked off, it fetches the newest available version of that image. So that's a manual process for me to build and push. That's something that could be automated with GitHub Actions. Although when I first put all this together, GitHub Actions didn't exist. So that's one reason I haven't done it yet. And then so if that makes sense, I'll move on. But let me pause before I do.
Yeah, that makes sense. I think okay. My next question would be probably moving to that is that the relationship between Docker and Kubernetes and where are they running on? So
yes, so overall, Docker provides a nice way to encapsulate an environment for running an application and all of its dependencies using Linux containers. And so for each of the different kinds of tasks that we want to do or services that we want to run, we define a Docker image. So that there's a few of those images here. And at the heart of it, the main thing to pay attention to in one of these Docker images is what's called the Docker file. And so this is a descriptive set of steps to create the image. And so when I talk about building an image, what I mean is running a command like docker build that reads this file, runs these commands one by one in sort of an isolated container environment, and saves the whole resulting file system as an image. So like this one, for example, starts from a base image that includes Java, and then it goes ahead and installs Python on top, and then it goes ahead and installs Ruby and Jekyll, and then it goes ahead and installs Node.js. And amazingly, you need all these things to build an IG. You need Java, Python, Ruby it with Jekyll, and Node. And it can be really annoying to manage all the versions of those things. So that's one of the places where Docker really shines, is I can define this set of 16 lines and know that anybody who builds this Docker image based on this recipe is going to have the right versions of all these dependencies, and they don't have to wrestle with their local OS configuration stuff. So that's an example of one of these images. And that's really the job of Docker, is to define these images and allow you to run one. And so in theory, we could just like spin up a virtual machine in the cloud and run a bunch of these images with Docker and take care. So if they died, we would have to restart them and set up all the right variables to pass into them. And that turns out to be like a fair lot of work to do it properly. And so that's sort of the job that Kubernetes does. I think it's called sort of a container orchestration tool. It's one layer up the stack, and it's basically a way to say, I want to have one copy of this, let's say, Zulip synchronization script. I want to have one copy of this running at all times, or I want to have 2 copies of this web server container running at all times. Those are the kinds of things you can do with a Kubernetes configuration file, and then Kubernetes knows how to load those configuration files and sort of do what they say. So I'll show you an example of, so this is not about IG builds, but this is about this is basically the web server that hosts all the IGs as well as the main FHIR spec. And so these files are the things that Kubernetes knows how to talk about. Services and deployments are sort of the language that you use to say what you want to run. And so a deployment says something like, hey, you know how I've got this Docker image for hosting a web server with the FHIR spec? That image is called CI build. And this deployment says, I want one replica of that image running at all times in my cluster. And if for some reason it dies, or somebody kills it, or it crashes, well, the specification says I should always have one replica running. So if it ever goes away, Kubernetes understands that it needs to restart that service. And then you point to what containers are, what Docker image should be running. And so this is an identifier for that CI build Docker image. And then you can pass in variables to that image. So when I run this CI image, which knows how to do the web hosting, it requires things like SSH keys and SSL certificates and all that sort of stuff. And so you can mount various files into the file system where that container is running, and Kubernetes knows how to sort of manage those mounts as well. So you can set up not just the code to run, but inject a few different files or environment variables that the code might depend on. And it's a little bit hairy, but in less than 100 lines, this describes sort of the whole web server configuration that we need to host build.phir.org. And Kubernetes makes sure that there's always one copy of this running. So that's an example of how we use Kubernetes together with Docker. And it's a whole sort of deep world unto itself, which is not the easiest learning curve, but it's at least like an ecosystem that has a very strong level of developer support and documentation out there. And so if I look back at this picture, at the end of the day, every time one of these jobs runs, it's supposed to either succeed or fail. For a long time, there were various intermediate conditions where it would basically crash without running the failure logic. Hopefully, we've rooted all those out. And so by the time the job is done, it is either uploading a successful copy of the built implementation guide to the web server. And when I say web server, I mean an instance of that Docker, of that Kubernetes deployment that I just showed you. So either it uploads the successful built files, or it uploads an error log. And when it does that, the web service container does a couple things with it. First of all, it sort of loads the files into a location on disk. So that location is a folder that looks something like this. It has a subfolder for every GitHub org where there's any content. And then inside of each of those subfolders, there's a subfolder for every GitHub repo where content has been built. And so if I look at things that are sort of recent, I see things from October 2020, February, March. I'm actually kind of surprised not to see anything from November. So it kind of makes me want to come over here to the build page and be like, what's up here? So like obviously here's one, HL7 PDDI CDS. This was built 5 hours ago, which was clearly in November. And so now I know what's going on here is these dates reflect the date at which the folder was created. So this is a folder that was created. This IG repo first came into being back in 2019. But if I go into it, I can see all the different branches that have been built. By default, it's showing me the master branch. But if I append /branches to it, I can see, there's actually 2 branches that folks have worked on, one called master and one called template port. And so what you see here in the URL structure is pretty much directly reflected in the file system structure of this web server. And so every time an IG is built, when it's pushed into that server, 2 things happen. First of all, the built HTML content is put into the correct folder on the file system. And then the second thing that happens is we basically run an indexing script. And this is super unsophisticated. And this is like one of those things that's just sort of grown in a way that I do not love. But just to sort of show where that lives, inside of the CI build Docker image, this is the one that's responsible for doing all the web hosting. There's this script called publish IG. This is what's responsible for receiving the incoming IG, and it basically receives that over a pipe from some SSH process. It puts it into the right location on disk. If there's already something in that location, it tries to atomically sort of swap them out. And then once it does that, it runs a little bit of indexing code. So no matter what implementation guide you upload, maybe I'm uploading some random feature branch to the smart app launch, one tiny piece of this directory tree. But based on that, then we're going to reindex the entire directory tree, every branch of every IG ever. The nice thing about doing it that way is, you never get out of sync or lose stuff. It's not super efficient, but it still only takes a couple seconds, so it's not a big deal. We basically search the entire directory tree of all branches of all IGs ever for all the build logs. And then we create sort of an index of those build logs called build.json. So it sort of just sticks the content in one file. And then it goes through that entire directory tree again, and it looks for any QA. These are the quality assurance JSON files that might be part of a build. At least part of a successful build. And it reads all those and creates a QAs.json file. So every time anything changes, we go ahead and regenerate the builds.json file and the QAs.json file by walking the directory tree and slurping up some stuff and sticking it into my favorite utility ever, which is the JQ command line tool, which just knows how to process JSON and add properties and remove properties and stuff like that. And the reason this matters, the reason we create these files, is to power this sort of dashboard. So under the hood, when somebody goes and wants to sort of see a list of all the FHIR IG builds, what this tool is doing, if I reload it, you can see the very first thing that it does is it requests a copy of that builds.json file, and it requests a copy of that QAs.json file. I don't know why it doesn't want to show these to me in line. Failed to load response data. Let me reload it after I've got this open. Anyway, not a big deal, but I can just open it in a new tab, and you can see this thing is basically just getting a list of where all the build logs are. And then, incredibly inefficiently, this web page then goes and fetches all the build logs independently once it knows where they all are. So then you can see there's dozens of build logs being fetched. And then once it gets them all, it renders this table. So it is not what I would call a great system, but it's been sort of just good enough to keep up with our usage. And the amazing thing I will say is like I wrote this dashboard view maybe 3 years ago, something like that, and it hasn't changed much other than a couple of like bug fixes. So it at least has been reasonably stable. So that's basically the pipeline.
And this lives on, it's a virtual machine on the Azure or a Google Cloud, or?
So it is a collection of virtual machines in Google Cloud, and they're actually not VMs that we maintain directly. They're part of what is called a Google Kubernetes cluster. So I can show you the configuration for this stuff, and if you want to get involved and you're interested in sort of the maintenance side of this, all this lives inside of a GCP project where the Kubernetes engine manages the machines in this cluster, and it's reasonably good about scaling things up and down. And so right now, this cluster has 1 node in it, 4 virtual CPUs, 16 gigabytes of RAM. But this cluster is configured with some auto-scaling properties. So if like 10 different authors all contribute changes to implementation guides at the same time, it'll just spin up more nodes in this node pool. So there's a few different pools here. These 2 are currently no nodes in them. This first one can scale up to 6 nodes without any intervention. And I just put a cap of 6 because like probably something's going wrong if that gets huge, and I don't want it to be 600 or 6,000. So I just sort of put a reasonable cap, and that's been fine. Each of these pools has like a machine type that lives in the pool. And the reason why this is the only active one right now is over time, like a few implementation guides have had really intensive resource needs. Like the average IG can probably build fine with less than 8 gigs of RAM, but like the UTG terminology implementation guide needs like over 20 gigs of RAM. And I didn't want to have custom handling for these different IGs. I thought it was going to be really confusing to try to manage. So I just cranked up the rules until basically all the IGs could build. And in the process, I realized that none of the existing pools that I had was configured with nodes that had enough RAM, so I just added a new pool. And so now I think this is the only pool which, well, I'm not actually 100% sure of that. We have to see what happens if I create more jobs. But Kubernetes is smart enough to know how much RAM your job asks for, and then stick it on a node that has that much free memory. And if there's not any node that has that much free memory, it'll look through the available node pools to find one with capacity and spin one up in that pool. So that all happens basically under the hood automatically. And you don't, I basically never come in here and tweak this unless I get into a circumstance where the UTG implementation guide needs more RAM than it used to. And then the other thing that's going on here in GCP is there's one persistent disk, which is mounted into the web server node. And so that's where the actual IG content gets stored for the web hosting. That's just managed as a Google Cloud disk.
All these mounts that you had in your configuration, they come from that disk.
So there's a couple of things actually to talk about when we look at all those mounts in the configuration file. So when we were thinking about that CI build dot deployment file. So there's the most important one is absolutely coming from that disk. And so the way this file works is you can have a list of volumes, which roughly correspond to folder structures that come from somewhere in the outside world. So this one comes from a Google Compute Engine persistent disk. and this is like the name of that resource in Google. And so I say, great, this is a volume that I want to have available to mount. This one, this volume here, doesn't come from a cloud disk. It comes from a type of resource that Kubernetes calls a configuration map, or a config map. And so this is really good for like small collections of config files that you want to be able to treat as a directory. And you don't need a like persistent cloud disk to store them. Kubernetes will just keep them in in memory or manage them somehow. And then you can mount those sets of config files in as you need them. So this one, for example, this config map is actually defined in this same directory. You can see sort of at least what it looked like originally. This is a config map. It's just a YAML representation, which has a data array, and then basically file name, contents. And so this config map has two main things. It has a public key for SSH, and it has some web server config data. So this is like a snippet of Nginx configuration that I want to mount so that I can tell my generic Nginx server about things like FHIR content types. So it knows to associate this FHIR plus JSON content type with .json. So that's a config map. It's basically configuration stored in Kubernetes itself. And then the third kind of volume that we're mounting here is very similar to a config map, but it's also managed by Kubernetes, but it's called a secret. And so instead of being a config map, it's a secret. It works just the same way, but with better access controls around it. And so this the SSL keys for the server, like for FHIR.org, are stored in a Kubernetes secret. All three of these things follow the abstraction of a Kubernetes volume. And so I can mount all three of these things into my system as volume mounts. So the job of a volume mount is to say, okay, I've got this volume defined somewhere below. Where should I stick it in the file system? So I say, great, I'm going to take this volume mount and stick it in etcsl. I'm going to take this volume mount from the Google Cloud Disk and stick it in var.dub, where the server's going to run from. And my config files, I'm going to mount into the right local paths for Nginx configuration. So that's the basic story about where that mounting happens. The Kubernetes command line tools give you like a pretty easy way to work with all these things. You can say stuff like, tell me all the config maps that are available in my cluster, or edit the secret named XYZ in my cluster, and you can open it up in a terminal and just make some changes directly, and it'll figure out how to propagate those.
And so that the disk image is where all the IGs and the core IG build, or just the IGs live there?
The disk image has the core, the easiest way to say it is the disk image has everything you see here, anything you can find at build.phir.org. All that lives in the GCE disk image. So it includes the main spec, all the branches of the main spec, and all the IGs and their branches. And there's some slightly fancy footwork that tries to make this URL structure sort of reasonable. That all lives in that Nginx config file we were looking at. So, that our config map sort of tells the web server stuff like, if the path looks like this, /IG, /some variable that matches this regex for an org, /some variable that matches the regex for a repo, but it has no terminal /, then stick a terminal / on it and redirect. And so if I go over here, and I forget to put the final / on this branch, I get redirected to one that has that final slash. Those kinds of rules all live in that nginx config file.
Right. Right. I think that was a great introduction. Is there anything specific you need help with?
Yeah, so, I mean, first of all, I'm well aware there's a lot to digest here, and don't expect most of it to make sense sort of the first time through, but hopefully that gives you at least a little bit of a framework for thinking about the parts. Practically, the question that sparked a lot of this discussion on the FHIR chat was, how can we better deal with default branch names that are not master? Because that's becoming by far the most common thing right now. If you just create a new repo on GitHub, is they'll nudge you to call your default branch main.
Right.
And nothing is actively broken, so it's not like a hair on fire emergency that we don't deal super well with these. But but there's a few places where we could obviously do better. One of them is just when you look at the build dashboard, this really only pays attention to master branches right now. And so functionally speaking, it would be great if this showed you, all the correct default branches by default. And, on a wish list, it would be cool if you could then drill in and see all the branches in one of these repos. That'd be like an example of something that we'd want to be able to accomplish. But in terms of steps to get there, I think one of the things that would be super useful would be slightly reorganizing the way we do this directory layout, this directory structure. Oh, you can't see my pointer when I point. That's unfortunate. I've been using my mouse to point to things without realizing it. Of course, it's not showing up in the share. Anyway, in the right-hand box here, this
now I can see it.
What's that?
Now I can see it.
Interesting. I don't know why, because I don't see it in my preview, but cool. Ha! That is interesting. Yeah, okay. So this directory layout right now, there's nothing special about master. It's a folder like any other, but we just sort of expect that if there is a folder called master, then it represents the default. And so there's special routing logic in this config file that says, for example, if you leave off a branch name, look for the branch called master and give somebody those files. That's sort of something that would be nice to improve. So that way, if somebody was coming here to the Smart App Launch IG, they would get the right content. It would be nice if they would get the right content, the default content, irrespective of what that branch name was. And so the best idea that I had for sort of how to fix that was basically, rather than trying to be clever and say like, well, here are a few different names that could represent the default branch and like try all of them, it might be better to pick something that can never be a branch name. I think like anything that starts with a period would be a fair string. I don't think you can have a Git branch that starts with a period. So have like .default and basically symlink that to whatever the actual default thing is. So something like that, so we wouldn't have to do anything super involved here.
Interesting. I see. Okay. So figure out the default branch without an API that gives you what the default branch is for this branch.
So yes, but actually I've already laid the groundwork for that part. So what I did last week was to take the image that's responsible for the CI build and, oh, sorry, I meant the IG build. And basically, every time I run an IG build, I'll paste in the link to this specific commit. So this was my update from last time was, there's a little bit of noise here, but this is the important bit, which is every time we build an IG, I call this function called isDefaultBranch, which just it runs git symbolic ref remote's origin head. This is more or less just a piece of Git magic that I found on Stack Overflow, but it gives you the name of the default branch. And I just compare that with the current branch and return true if they're the same and false if they're not. And so every time I build an IG, I compute that Boolean, true or false, and I take that value and I include it when I call the publish script. So now when I send the published IG content to the web server, I tell the web server what the org was, what the repo was, what the branch was, whether it succeeded or failed, plus whether it was the default. And so I'm not using this value at all right now, but I'm sending it along so that whenever this publish script runs on the other side, it's receiving that 1, 2, 3, 4, that fifth variable, which will tell it whether it was the default or not. And the value of that thing will either be the string default, if it was the default, or the string non-default, if it wasn't. So that way, by the time we're actually receiving the contents, we don't need to go and look anything up. We've been given that information.
Okay.
And so the magic then, the missing steps would be more or less this publish IG script. This is what's currently running and receiving these variables. Right now, it's only trying to parse 4 variables, but the next step would be to also parse a 5th variable, which will be that default string, and then do something based on what that value is. So this is, I think that with like the right amount of tweaking to this script, we've got all the information we should need to put files in the right place. I only know like enough bash to relearn how to write a bash script every time I need one. So I probably have to go and remind myself how this thing works. But basically, the bottom line would have to be like, after we copy files into the web root, we would optionally create a symlink to them if it was the default. Something like that.
Mm-hmm.
So, depending on your interest and interest in rolling up your sleeves and working on some of this, that might be a good kind of first project. That was one that had come up in the chat.
I see. Yeah. Okay. That makes sense. I'm keeping notes here. Hopefully, I'll understand them.
So yeah, all right. I'm going to turn off the recording at this point. You can see if there's anything else we want to talk